Hello, today we're going to work on a problem of determining the empirical formula of a compound, and this problem is going to ask us to determine the empirical formula of ascorbic acid. Now, we need to have some information about ascorbic acid, and in this particular case, we're going to have the information of the percent composition. And the percent composition is the following. We're going to have 40.92% carbon, 4.58% hydrogen, 54.50% oxygen, and these are all by mass. And so this is our goal, to figure out the empirical formula. And our empirical formula ultimately has to get us to have a relationship of the atoms to one another. And so when we think of the goal and the process of what we're doing, what we're going to first have to do is get our grams that we have of each element to the moles of each element. And then once we have that, we can ultimately figure out what our ratio of elements are to one another to give us our empirical formula. And in this particular case, we know that we have 40.92% carbon, 4.58% hydrogen, 54.50% oxygen. Now, you'll notice that all of these percents, when you add them up, add up to 100%. So what we can do is we can assume that out of 100%, let's say we just have 100.00 grams. And if that's the case, that means 54.50% oxygen is really going to be the same as 54.50 grams of oxygen. And the similar case for the other ones of hydrogen and carbon as well. And so if that's the case, now we have grams. And so what we need to do for each one of these, so we need to convert the grams of each one of these into moles of each. And if you recall how we convert grams into moles of each is to use, of course, our molar mass. So the molar mass of carbon, of course, is 12.01 grams of carbon for every 1 mole of carbon. And to 4 significant figures, we have 3.407 moles. Similarly, we're going to do this for hydrogen. We have our 4.58 grams of hydrogen, our molar mass of 1 mole of hydrogen for every 1.01 grams of hydrogen. It's going to give us 4.54 moles of hydrogen. And then finally, our oxygen is 54.50 grams of oxygen, and our molar mass is 1 mole for every 16.00 grams of oxygen, giving us 3.406 moles. Now what we need to do is we need to compare all three of these number of moles to one another and determine which is the smallest. And when we look at these, it appears that the one for oxygen seems to be the smallest one. And so what I'm going to do for carbon and hydrogen and oxygen is that I'm going to take each one of the moles that we've calculated. That's for carbon, that's for hydrogen, that's for oxygen. And I'm going to divide them all by the smallest, which happens to be 3.406. And when I do that, for this one, this gives us 1.000. This one gives us 1.33, 3 significant figures. This one to 4 significant figures is 1.000. So what that's showing us is that the ratio of carbon to hydrogen to oxygen is a 1 to a 1.33 to a 1. Now you can't have 1.33 hydrogen atoms. And so what we need to do is we need to multiply this by something to give us whole numbers or something very close to whole numbers. And the best that we can do is to multiply by 3. And when we do that, it changes hydrogen, carbon, and oxygen, each one, to 3 times what that is in this particular ratio up here. This one's going to go to 3, this one's going to go to 4, and then this one's going to go to 3 as well, giving us our empirical formula. And this is your standard type of empirical formula problem.